This video presents FastEventDGS, Deformable Gaussian Splatting for Fast Dynamic Scenes from a Single Event Camera, from Shanghai Tech University and the University of Zurich. Reconstructing fast-moving 3D scenes is essential for AR/VR and robotics. However, conventional RGB cameras suffer from motion blur and low temporal resolution, limiting them to moderate motion scenarios. Event cameras offer a compelling alternative. They detect brightness changes asynchronously with microsecond latency, producing no motion blur. Despite their advantages, event cameras produce sparse, noisy output with no absolute intensity. Existing dynamic reconstruction methods all rely on auxiliary sensors like RGB cameras or LiDAR, adding hardware complexity. This raises a key question. Can a dynamic scene be reconstructed from a monocular event stream alone? FastEventDGS answers yes. It is the first event-only dynamic Gaussian splatting framework. Given only event streams and camera poses, it introduces four innovations: a continuous B-spline trajectory for arbitrary timestamp supervision, dual event generation losses for photometric and geometric constraints, a local patch event motion loss for explicit motion guidance, and a refinement stage with VGGT depth correction and noise regularization. Without explicit motion guidance, deformation fields overfit to training views. The proposed local patch event motion loss compares each Gaussian's projected trajectory against the surrounding event pattern in a spatial patch. This enforces spatiotemporal consistency and prevents overfitting, analogous to optical flow supervision in RGB-based methods. Without absolute intensity, depth estimates drift geometrically. VGGT is used to predict scene depth, and a scale-invariant log depth loss aligns the Gaussians accordingly. Noise regularization further suppresses spurious Gaussians and promotes smooth gradients, yielding geometrically accurate, noise-robust reconstruction. The method is evaluated on Blender Dynamic Event, a new synthetic dataset with 4 scenes. The following slides show video comparisons against the baselines. In the butterfly scene, FastEventDGS and E2VidDGS produce blurry results, while FastEventDGS closely matches the ground truth. In the duck scene, FastEventDGS produces clean geometry with fine surface details, outperforming all baselines. The alarm scene features a rotating structured object. FastEventDGS faithfully captures geometric details that baselines fail to reconstruct. The ball scene demonstrates fast translational motion. FastEventDGS achieves an average PSNR of 22.91 dB, a plus 5.15 dB improvement over the best baseline, E2VidDGS. On the real-world Gen 4 dynamic dataset, FastEventDGS reconstructs the napkin scene robustly despite real sensor noise, outperforming Event3GS, FrameDGS, and E2VidDGS. The pillow scene further confirms that FastEventDGS generalizes well to real-world conditions. In summary, FastEventDGS is the first event-only deformable Gaussian splatting framework for fast dynamic scenes. Key contributions include continuous trajectory supervision, a novel event motion loss, VGGT-based depth correction, and 2 new benchmarks. The method achieves plus 5.15 dB PSNR over the best baseline. A current limitation is the reliance on known camera poses, which future work will address. Code and data are available at github.com/DGS/FastEventDGS. Thanks for watching.